In this talk, I'm going to have a very short discussion how we can use theory of constraints in identifying the optimal product mix. The problem may have hundreds or thousands of constraints, but in the framework of the theory of constraints, we assume that we have identified the bottleneck, and there is only a single bottleneck. And that is the whole philosophy of the theory of constraint, that don't get lost into many constraints. Identify what is the governing constraints, what is the binding constraints, what is the bottleneck, focus on that, utilize that constraint in the best possible way. By the way, I have other lectures on theory of constraints. For example, you may look at this one, in which I also identify the optimal product mix in a more detailed example. Professor Mandyam Srinivasan, the author of the book Building Lean Supply Chains with the Theory of Constraints, go through two examples, two computations for this problem, one based on standard costing and one based on activity-based costing, and shows that when you incorporate fixed costs into the decisions that are not related to those fixed costs, that you are not allowed to break those fixed costs on these activities, you come out with wrong decisions. I have summarized them in these 2 pages, but here I am only going to go through how to solve the problem. So one lesson we learned from the theory of constraint is identify the constraint, identify the binding constraint, the bottleneck, and do not include fixed cost into decisions that you are going to make about this constraint. In this example, we have 4 products, and we want to decide how much of each to produce. These are the markets for these 4 products. These are the revenues, and these are cost of raw material. So if I subtract these numbers from revenues, I will get profit margin, or something that we call it profit or financial throughput. This is the rate at which each of these products bring money into the company, no matter how much fixed cost is there, because the fixed cost is already there. So this would be 100, 160, 130, and 175. These are dollar values. Each unit of these products bring into this company. Obviously, this is most profitable product. Therefore, we may think that is at our benefit to produce that product, then this product, then this one, and then this one, because profit per units are coming down as we move from this one to this one. However, that is not at our benefit, because these products consume the bottleneck resource at different rates. Therefore, what we may want is to divide profit by the consumption rate, which gives us 50 here, 40 here, 43.33 here, and 35 here. You see, this 100 is now turned into 50, while this 175 has turned into 35. So we first produce this product, then this, and last this. But let's see if our capacity allows us. And the person who brought the philosophy of the theory of constraint into academia was Eliyahu Goldratt. Sadly, he passed away 2-3 years ago. A person who has done a great job on what Goldratt did is Mandyam Srinivasan with his great book, Building Lean Supply Chains with the Theory of Constraint. And that's a qualitative book, and I'm sure when you read it, you will enjoy it. I start producing this product. One other thing that we learned from the theory of constraint is constraints are partitioned into external and internal. The key external constraint is market. The key internal constraint is capacity. Also, policies are considered as a group of internal constraints, but in this example, we only focus on market constraint, external constraint, and capacity constraint, internal constraints. Demand for this product is 250. Each unit of product consumes 2 units. Therefore, to fulfill the market demand, we need 2 times 250 equal to 500. Based on the statement of the problem, we have 1,000 hours minus 500. It leaves us with 500. Now we go to the second most profitable, which was this one. It was 200 minus 70 divided by 3, 130 divided by 3, and it was 43.33. It was the second most profitable product, the second product with maximal financial throughput. Each unit of that brings this many dollars into the company, and we call it financial throughput of one single unit of that product. Demand is 145. Each unit of product consumes 3 units of resource, and that would be 5, 3, 4. And we had 500 hours. If we subtract it from this one, we will get 65 hours. The next profitable product was this. Demand is 160. I have only 65 hours. 65 divided by 4, 1625. And details of these computations are also here. This is what we produce of each product. These are the units of consumptions from the bottleneck resource. These are the financial throughput or net profit they create per unit consumption of the bottleneck resource. And these are profits per unit of product. If we multiply these numbers by these numbers, we will get this profit, which is maximal. No other solution under these internal and external constraints can create a profit more than this. As I explained at the beginning, I also have another recording here at this site. Thank you very much for attending this session.